Okay, polar to rectangular form. Well, first of all, this picture right here, it's kind of got, well, it's sort of like if we've got rectangular and we've got polar all in the same place. It's kind of a mix of both. It's kind of like a chimera that we were talking about. Part human, part animal. It's a weird concept. They're having real trouble getting it to work in the latest news, which I don't think they should. Anyway, you're going to be mixing rectangular and polar today and trying to like take things that are in polar and make them rectangular and take things that are in rectangular and make them polar. So you're going to have to be able to go back and forth. Can you tell which one's which? Which of these is representing the polar side? The r and the theta. Which of these is representing the rectangular side? So what? And if we can get them to relate to each other and say, well, this is equal to that, that'll help us translate things. So, would you agree that in a right triangle, which this appears to be, that x squared plus y squared should equal r squared? All right, write that down, because it'll help you remember it. Because you're going to use that a gajillion times on the test and for the next few days as we're preparing for the test. Now, do you recognize that as the equation of a circle? Maybe you don't, but this is one of those topics that's on the ACT. That would be a circle that has a radius of what? 4. And its center isn't at 0, 0. It's been moved. Is it moved up or down? It feels like down, but it's on the inside of parentheses, so you can't trust it. So it's been moved up. Yeah, so it's been moved up 3, and it has a radius of 4, so it would look something like that. Does that make sense to you? All right, that's an equation of a circle. Well, let's relate that to polar for a second. Do you get that polar? If I just said r equals 4, that means a circle. Because if r equals 4, it seems like, well, you've got a dot somewhere, but you've got a dot everywhere. Unless they tell you which angle, it's like all the angles. I mean, 4 comma 0 would be here. Okay, r comma theta, right, in polar. 4 comma pi over 6, that'd be like a normal one from yesterday, where I'd say, where is 4 comma pi over 6? And you'd say, okay, so I'm going to say pi over 6 is a 30-degree angle, so it's like there. And 4 means go out a radius of 4. So it's right there. You get how that is 4 comma pi over 6? And if I just keep making a whole bunch of those, do you get they're just going to keep going around in a circle here? And if I don't know which angle it is, it's all of them. So r equals 4 means you got all these. What's the equation for that in rectangular? You take r equals 4, and I'm going to square it. I want you to think about why. Because that other equation says x squared plus y squared equals 4 squared. That's why I'm going to square it. I'm going to square r, make it r squared, and square the 4 and make it 16. So if r squared is 16, do you get, I can put it right there, and I can put in 16, and now poof, it's rectangular. Why is it rectangular now when it wasn't before? Because before, I didn't have an x or a y in it. So what's the polar way to write a circle with a radius of 4? R equals 4. That's it. That's all you need to write it in polar. What's the rectangular way to write a circle with a radius of 4? That. So if you're going to get this to turn into that, you have to know both. I like to, one of the easiest ways to just think of it is this. If you know this equation, you can just stick in the 4 in where the r is. And once you have an equation that's only got x's and y's, you've turned it into a rectangular equation. All right. So let's hark back to one of the ones we just did before. People have usually no trouble finding this, 2 comma 3 pi over 4. Everybody find that spot. It's not difficult. If you have caught on to polar at all from yesterday, this part should be easy. Would you please put the dot in the right place? Remember, it's just a dot. Drawing a line on your iPad from the origin to your dot helps me to see where you put it. But really, that's just a dot. Would you please turn your iPad my way, and I'll tell you if you have put the dot in the right spot. Tick the dot spot. Yup, 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 yup. Okay, everybody that's showing it to me, yup, yup, has gotten it right. I know there's a few people that might not know, but here's a reminder. Here's where 3 pi over 4 is. And then how far out do I go on this line? 2. Now, how far is 2? That's up to you. Let's say that I decide that's going to be far enough. There we go. Okay. Now, in the old days, as of yesterday, I taught you to go, that's x, that's y, and you can write an equation for that, right? And this is what degree angle? 45. Would you agree that this would be a safe statement? The cosine of 45 would be adjacent, which is x, over hypotenuse, which, do we actually know the hypotenuse on this one? Yes, we do, because it said 2, so this is a distance of 2, so it's x over 2. Now I want you to just think that through for a second. Wouldn't it be true if I times by 2 on both sides? This is 2 cosine 45 equals x. I got it down to just an x. I've got polar on this side, and I've got rectangular on that side. So, which is this? Is this a polar or is this a rectangular? Well, it's just telling me how long this side is. This side is that. I'm going to give you a secret. There's a way to do this way easier, and I wanted you to see it in the picture first. This other way I'm about to show you means you don't even need a picture. If you want to change polar to rectangular, all you got to do is go, x is always going to be the r times cosine of theta. R cosine theta. You won't even need a picture from now on. If I give you a point, 7 comma pi over 6, you can just automatically go, whatever r was, times cosine of theta, that's x. And take a wild guess what y is going to be. Since x and cosine kind of go together, r sine. And if you look at this picture, you might be able to see better why it's cosine of 45 would be, I just did cosine, sorry, sine of 45 would be so opposite over hypotenuse y over 2. So if that 2 can just come over here, I have y equals 2 times sine of 45. R times sine theta. All right, where else could I have gotten that x equals r cosine of theta? If there was only one diagram from today that I'd want you to remember, it was this one. That's x. What was that one? Y. What's this one? R, because it's like on a circle, and that's the radius of the circle, right? I'll make it my board's out of alignment, and it causes all kinds of chaos. There we go. And then this is theta, right? Watch me do cosine on this. Cosine of the angle is equal to what? Adjacent over hypotenuse. What? X over r. And then if I just multiply by r on both sides, see why x is always r cosine theta? Memorize that. X is r cosine theta. Y is what? R sine theta. And x squared plus y squared equals r squared. Now, I want you to see that this one diagram has all those things in it. This one picture has all of that in it. And in fact, it's even got one in it that I haven't said. I'll write down what I have said. I have said x squared plus y squared equals r squared, sorry. And I have said that cosine of theta is adjacent over hypotenuse, so x over r. And then I just was smart and put the r over here instead. X equals r cosine theta. And then I did sine theta is y over r, and then I again got smart and put the r over here. And now I have three really good equations, and which one is begging to be written but hasn't been? Tangent. Tangent of theta is what? Y over x. Notice the first one where I didn't have to tweak the equation so that I could keep the polar separate from the rectangular. Do you get rectangular? Polar. Here's the polar part. Rectangular. You want to separate them. You want to keep them separate. Polar. Rectangular. Polar. Rectangular. All right. So, do you get that by giving you this, I have just given you a polar equation? Do you get what its shape is? A circle. Do you get that you can write that as a rectangular equation, which will need what two letters? X's and Y's. You can write the general form of it, or you can do whatever you want. I want you to figure out what's the equation for that right now. I like to just say x squared plus y squared equals r squared. And so I look at it and go, okay, it would be really nice if I had r squared. So I just square both sides. There. R squared is 64, and then I can just stick it right there. There's other ways to do it, but that works. X squared plus y squared equals 64. That's what kind? Is that polar or rectangular? That's rectangular. Okay. Now, I want to just look at r equals 8 again from a different perspective, and this might blow your mind a little bit. There's another way to get r squared instead of squaring both sides. Isn't timesing by r the same thing as squaring r? But if I times by r on both sides, I want you to think about this for a second. It doesn't come out to r squared equals 64. It comes out to r squared equals 8r. What's the problem with that? I could divide both sides by r, but that'd be dumb. I'd be back to r equals 8 again. Yes? And you're saying I should stick in an 8r over here. The only problem is that then I still have an r in my equation. Gotta get that r out of there somehow. Yes? Oh, since r equals 8, then that can be an 8, can't it? I know that's kind of dumb, but my point is, you can multiply by r on both sides, and trust me, there'll be a time you'll need to do that, because squaring won't work, but timesing by r will. I'll say that again. Squaring doesn't always work on this kind of problem, but timesing by r on both sides can work. All right, one more thing. We do agree that that is a not polar equation. That is a rectangular equation. Okay, what if I had to change it into polar? Do you know what y is equal to? There's a little formula for that. If you had to, you could go back and draw this guy real quick. X, y, r, theta. And what's y equal to again? It has an r in it. So sine theta equals y over r. So y is equal to r sine theta. Oh, that's right. He said that before. I remember that now. Y is r sine theta. R sine theta. And x is r what? Cosine theta. And now, have I changed it into polar? Yes, I have. But there's an even cooler way to do this one. I got these replaced. I only have r's and thetas, so it is polar. But there's a cleaner, kind of more elegant solution. Would you agree that I'm allowed to divide by x on both sides, and I can say y divided by x equals root 3? Do you know why I just did that? What's y over x? Tangent. So tangent equals root 3. Now you might be asking yourself, wait a minute, you're saying that that's rectangular, so that means this isn't rectangular anymore? What is it? It must be polar. Because instead of just giving you an r, in this case, they're just giving you a what? What's the only variable left in this thing? Tangent is not a variable. Tangent is a function. The only variable is a theta. Does that sound like r theta? Do you get how this one, all you have left is a theta? And by the way, they usually want it solved for theta. So quick reminder, how do I get tangent off of there? Can I just like cross it off? No. What undoes tangent? Inverse tan. Now I just got theta. How can you have just an angle? Well, remember before we just had a radius and it made a circle? What if you only had an angle? Just having a radius meant you're going to be a radius in every direction. Just having an angle meant an infinite number of radiuses that are on that angle. So let's pick an angle that's easy, like pi over 6. Did you agree that's kind of the angle pi over 6? But I don't know where the r is, so r is everywhere. R is here, and here, and here, and here, and here, 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 here. And it goes this way, too. And do you get that that's actually an equation of a line? And do you get that you don't have to have an x and a y to make a line? Let me just do that. Do you get, I don't have to have just an x and a y. I can have an equation like that. Y equals 2. See? Only has a y in it, and yet it's a line. This is polar. And if I only give you an angle, it still can make a line. If I only give you a radius, then I can still make a picture. Radius is 3, makes a picture. All right. So, how about just x equals? Let's say that's x equals 3. It only has one variable. It's got an x. That makes it rectangular, and I got a whole line out of it, even though it's only had one. Okay, so if I give you this, you should have something pop into your head. What? X. If I do this, what pops into your head? Y. If I say this, what should pop into your head? R squared. That all comes from one picture. X, Y, and what? R, and what's this? Theta. All right. Now let's start your homework. Everybody find your homework with me. I'll pause while we... Okay, for this first one, on number 14, let's do it together. Everybody gets confused on these. I even get confused on these unless I really think it through carefully. About, well, where the heck is negative 2.5 comma negative pi over 4? First, I encourage you to not even do the negative here. I would encourage you to find 2.5 comma negative pi over 4. Find that spot first. Is it the same spot? No. But it's easier to find, and it'll tell us where the other one is. Negative pi over 4 is like that. 2.5 there. That's the spot 2.5 comma negative pi over 4. That's so much easier to find, to me anyway. And once I've got that one, do you get the other one must live over there? So this point is actually here. And again, I don't recommend you try to find it directly. Find it by finding its helper point. And this is not the answer. That is. Okay. Now, what are some other names for that point? This is just all this gobbledygook in here is saying is find me ones where r is less than 0, so where, as in where r is negative. I already got one of those. But they want the angle to be positive. So how could I write this thing with a positive angle? Well, if I had just said, here's a point, tell me where it is, I hope you would have said, oh, that looks like 3 pi over 4, and that looks like it has some distance, I don't know, maybe 2.5. 2.5 comma 3 pi over 4. And then you just got to figure out which kind don't we have. We have one with a negative r and a negative angle. We have one with a negative r and a negative angle. That's the same one. That's a repeat. Sorry. And we need one with a negative r and a positive angle. Those come from here. I'd be thinking 2.5 comma, what's another way to say this with a positive angle? For this spot, which is the one that helps you find this spot, it's that angle. A whole bunch of pi over 4s. So this spot is 2.5 comma a whole bunch of 7 pi over 4s. Good. And that's not this spot, but it helps me find this spot because now I can do the opposite of it and bring it over here and make it negative 2.5 7 pi over 4. Yep, this is just a repeat in last night's homework except for one little thing. It asked at the very end to make one where the radius is positive. Okay, I got that kind. And the angle's bigger than 2 pi. Do you get, you can also make these by taking your angle and adding 2 pi to it. Okay, so that's like this kind, except we're supposed to add 2 pi to this. I'm going to choose to add 4 pi over, I got to add 2 pi, hold on. 2.5 comma 3 pi over 4 plus 2 pi, also known as 2 pi over 1, also known as 8 pi over 4. That'll make the total angle here 11 pi over 4. Okay. This one freaks people out because they think it's 2 angles. It's not. Which one's the angle? The first one or the second one? The second one. The first one's just a number. Isn't pi just a number? Yeah, it's 3.14. I know it's technical, it goes on forever, but 2 times 3.14 is about what? 6.28. So it's just 6.28 rounded, comma negative pi. Figure out where it is. Write some other names for it. All right. Then in this page, all review of yesterday. And it feels a little bit too big, so we'll cross off 19 and 20. 29. And then, on this page, this is where the rubber meets the road. This is the actual, these are actual changing to equations problems. The other ones were all review of yesterday. Okay, this is the new stuff. Let's do one together. X equals, well, what's wrong with it? It's an equation. X equals -3. It looks like this. The line goes like that. Well, I can change that to polar. But I can't have an X in it anymore, so do you know what to substitute in for X? R cosine theta is equal to X, right? So I can just swap out an R cosine theta for that. I crossed off an X with an X. I'll scribble it out. How about that? It becomes R cosine theta equals -3. And some people are bothered because they're like, well, don't you have to know one of the two? No, you don't. Just like, question?
Is that going to be our final answer?
I know, that's what I'm saying. A lot of people are like, that can be the final answer. Yes, it can be. Because isn't there equations that have an X and a Y in it? You can have two variables that have in an equation. Like if I said Y equals 3X, that's an equation, right? It's got two variables. It's okay to have two variables. Now, it does sometimes say you want you to solve for R. Look at that. Solve for R in all but 60 through 63. That means I should solve for R here. Not that hard. How do you solve for R? You get the cosine off of there. So I can go, what gets cosine off of here? I could divide by cosine on both sides. Or, let me think if there's another way. How else could I get cosine off of there? No, I can't use inverse. Yeah, I have to do it the way I just did it. There, solve for R. Okay, another one of those formulas I gave you. X is R cosine theta. What's Y? R sine theta. So that one's a super easy one. This is the one. Do you remember what I did on this one? I had one exactly like, in fact, I did that problem earlier. What'd I do? I divided by X. Why did I divide by X? To get all of the rectangular onto one side, and then hopefully you'll recognize, oh, well, I remember what Y over X is. What is it? Tangent. And why can't I just stop there? Because it says in 60 through 63, you need to solve for theta. All right, so I need to solve for theta now. So how do you get the tangent off of there? Inverse tan. And then you'll have theta alone.
So do we actually type in inverse calculator?
No. All you were doing is writing me an equation. And the equation should say theta equals blah. So I got to get this off of here so I do something to both sides. All right. Now this one. If I want to ask, is this in polar or is this in rectangular? That number 70 there. That's rectangular. So I got to get it to be polar. So do you see the x squared plus y squared part? I know what that's equal to. What's that? R squared. And that'll give it an r. And then I got to get the y out of there. Once I get the y out of there, it won't have x's or y's anymore, and it'll be in polar. All right. I know it's going to take a little while for this stuff to process. All right, last one. We're going to skip 78 and 86. And these, we've done them before, and I gave you a hint that you don't always want to square both sides. There's another way to get r to become squared. All right, that's all I got for you. You can skip those last couple. That's all I got for you for today.